Today we're going to look at significant figures and what they actually are. Okay, so significant figures allow us to quote a degree of accuracy for numbers, mostly with measurement, but other things as well. Okay, and we're going to start and look at it in terms of our jackpot that we've won down there. We've won a jackpot, $14,856,292.36. Okay, that's the brilliant amount of money we've won for the jackpot, and we're going to go around and tell our friends, families all the time. We're going to keep going, etc. We won this amount of money. But if we did win this amount of money, we more than likely wouldn't be sitting there and saying the whole number all the time. Not only is it a long amount of time, but actually it takes a while. So we might round that in our heads. So if I turn around and said, okay, we've won 14 million, 14 million is actually not the accurate amount of money, is it? There's $856,000 left there. So we may turn around and say we've won 15 million. So whilst it's not necessarily accurate, it is actually going to be closer to the amount that we've won or anything like that. Okay. So when we talk about significance, we talk about the idea of how significant certain things are. In this number, 10 million is bigger than 4 million, which is bigger than 800,000, which is bigger than 50,000, which is bigger than 6,000. The bigger numbers are always on the left, okay? So the most significant is here. $10 million is the most significant here. And if you think about that as a number and a value of money, that makes sense. And the same thing makes sense that the 6 cents is actually insignificant, especially if you have won that amount of money, right? It's all about the millions of dollars you've won, not the 6 cents that you've won, right? It just doesn't make sense, okay? So it starts from most significant to least significant as we move from the left, okay? So in this case, if we were to sit there and round this, so if we wanted to round this to two significant figures, what we have to do is we have to sit there and go to our original number, and we put a line after the second significant figure. Now that 1-4 represents 14 million. So it represents 14 million. Okay. And so at that stage we have a choice to make. We are either going to say, is it 14 million or is it 15 million? Okay. And to do that, we always look at the next number along, or say in our heads, and we look at the next number along and we go, is that bigger or smaller than 5? And in this case, if you think about it, 14,856,000, is that closer to 14 million or is it closer to 15 million? And in this case, it is closest to $15 million. Okay, so we must make sure that when we're doing this, we are looking at the next number along. Is that closer to 5, above 5, or not? And if it is above 5, we round this up. We never round down, so never, ever, ever round down. Okay. Right. So always, hold on. Always look at the next number after. Okay, if 5 or more, round up. If under 5, stay the same. Never round down. The other thing to bear in mind is that when we do these questions, it's 15 million. It's not just 15. The answer's not just 15. It's 15 million. So we have to still have the same number of digits in the number. Okay, we don't just say, write 15. It becomes 15 million. Okay. So if we're sitting there and saying, okay, well, let's have a look, and we're going to do this to, let's say 5 significant figures in this case, 5 significant figures. We're going to go back to that original dotted line that I've got going on here, and I go to the top and I go 1, 2, 3, 4, 5. So that's where my line is now. So straight away, think about that in terms of numbers. That's 14,856,292. So the fact that we said 1,000 just before the fact that we did that line means that our number is either one or two numbers. It's 14,856,000, or it's 14,856,000, and then we have to make a decision. Let's just say, sorry, start again. 14 million 857,000. They're the only two options that we have. So what we need to do is we need to look at the next number after that line. The next number after that line is a 2. So in this case, it says under 5. If it's under 5, it stays the same, never round down. So it stays the same. So therefore, our answer is $14,856,000 in this case. All right, and so on and so on and so on. And that's okay for everything, right? Okay, that's okay. But what happens if we have a smaller number? Okay, so I'm just going to put that. What happens if we have a smaller number? That's the question. So if we have a smaller number, okay, and when I say a smaller number, actually, let's put that as what happens if we have a number smaller than 1. So imagine we're dealing with a quite small number here, and we're trying to say, okay, let's say 0.004639. That number there. We don't know what that's because it's not necessarily got any units to this case, but it is a number smaller than 9. Okay. The thing about smaller than 9 is the fact that when we're doing, let's just say smaller than 1, if we're dealing with a number smaller than 1, what we've got to remember is we've got to remember that leading zeros are not significant. So in terms of our significance, if we were dealing with this particular question that said let's go to one significant figure here, okay, our first significant figure, we ignore the zeros. The zeros don't get included when we're dealing with significance. So our first significance is actually 4. That's our first number. So we put a line after the 4 and we write the whole of that number there, 0.004. And the other option is 0.005. They're the only two options that we have. Okay, they're the only two options we have. And just like last time where it says, look at the next number after. What's the next number after this line? The next number after this line is a 6. If 5 or more, round up. So that means that we need to round this up, and we need to round it up to 0.005. As a few of us might be saying, well, why don't we put the rest of the zeros? Well, we can put the rest of the zeros, so 0, 0, 0 after that number if we wanted to. But in terms of a smaller number, a number smaller than 1, in this case, it doesn't make any difference because 0.005 is the same as 0.005 with some zeros at the end. It's not the same as this. If we just left it as with $15 is completely different to 15 million. So we have to watch out for that. Okay. The only other thing I'm going to talk about today is what about zeros in the middle of a number? All right. What about zeros in the middle of a number? That's the next question we're going to talk about. So for example, we have this number here. Let's say we have a number of being 1.30259. Okay. And the thing to bear in mind in this case is once we have started counting significance, zeros then count. And that's the thing to bear in mind in this case. So let's say we turn around and want to round this number to 3 significant figures. Okay, to 3 significant figures. What we need to do is we need to sit there and go, right, well, that's our first significant figure. That's our second significant figure. Our third one is the 0. The 0 in this case counts because we've started counting, so we have to include it. So we then put a line after this and we go, right, our number is either 1.30 or 1.31. Go back to the rule, look at the next number. After the line is a 2. If under 5, the number stays the same. So in this case, our answer is going to be 1.30. And that's a brief introduction of how we use significant figures for our accuracy.